to find the execution time in a model. So for that, we just need to import the pandas here. So using the CSV file, like we have to do the same task as we are doing in that finding the accuracy. So for that, we just need a data set. So I have taken here a data set, that is Irish data set. This basic data set you can find it anywhere on the platform. Like when you have entered, when you will enter the Irish data, then it will give you the data set. So for that we have just taken Irish data set, and here you can see the different attributes consist of sepal length, sepal width, petal width, and class. So we have just taken in X variable, we have just taken 0 to 4, like sepal length, sepal width, petal width, all the numerical values. And in Y variable, we have just taken the objective type, like object type is here class. So we have just taken that Y variable as class. Now to print that means what is the Y head is to what is Y. So we are just putting here Y dot head. So it will give you the classes, different classes, like top means the 5 classes from the data set. Now to do accuracy means to find the prediction, we just go for classify here, that is SVM. Before that we have to split the data set into two sets, that is training set and testing set. So for that we are just taking x and y. As you know that x and y are the two different variables, so for that we are just using that thing only. And after the splitting, we are just putting a classifier, that is SVM. So it doesn't matter here, you can take any classifier which will give you better accuracy. So now we will just, here you can see that vibrate, it will give you the prediction value. So to find the execution time, we need to just import time here. After that we are just making a variable start. After that we are just assigning that to time. And after this wirespread we are just putting another variable, that is and, will give that is time.time. Now print here, just write the print here, and here we'll just write time sequence. After that we'll just go for end minus start. Okay. So here you can see the time sequence from the model. To implement this is 0.005 seconds. So it is a good time. And so you can work on this. It will give you better time also. So let us see the accuracy here. It will give you the 91.3 accuracy. It will give you 91.3 accuracy, which is far better. So yeah. So this function, like import time, this cosine number cell is saying that how to find the execution time to perform a model of a model. So here we once again I'm just clearing, like for that only we just need to import the time here package. After that we are just putting means need to write a variable before the vibrate, and after the vibrate we are just putting another variable, that is end. Before start and after that we are just putting another variable, that is end. So as we know that end value have or greater, and value will be greater, so and the start value will smaller. So for that we just need that the n minus start. When we go for n minus start, then it will give a positive value. If you write here start minus n, so it will give you the negative value, and that negative value is not perfect for our so finding the means time taken, execution time. So for that only we are just using n minus start here to subtract the end variable to start variable. So here we're just getting 0.005, and basically the SI unit or unit is the unit is second. So this takes almost 0.005 seconds to complete the task. So yeah, it is less than 10 to the power 2, 10 to the power 3. So it is a good result. And after that we are just finding the accuracy. So you can see the accuracy is also 91.3, which is a good accuracy, which is means our classifier is working well, and it's giving a very good accuracy here. So thank you.